Hi, everyone. A very good evening to all of you. If you can hear me, could you please respond? Please confirm if you can see me and hear me. Yes? Okay, great. Hi, Sharath, if you're there, could we have you on screen, please? All right. Thanks for confirming. Yep. Right. Great. Hi, Sharath. How are you doing?
Hello.
Hi. Can you hear me now?
Yes, this is Sharath.
Hi,
Uh,
Sharath.
Hello.
Great to have you. Great to have you here. Looking forward for a great discussion. Um, I'll just give a very brief introduction of you, but we'd like to hear more from you about your journey. How you came about, and probably just 5 minutes if you could take us through it. But for the benefit of all our audience today, Sharath Chandra is a principal data scientist at Microsoft. He's been with Microsoft for the last 3 years, and his main areas of specializations include large language models, responsible AI, deep learning, including Gen AI, ChatGPT, and technologies like that. So prior to that, also he has worked in different companies. But Sharath, like I said, we'd like to hear more about your journey. Because you started somewhere else. You started with aerospace or something like that. You've switched domains. You've switched technologies. The reason I'm asking you to take us through your journey is because that is very pertinent and relevant to our audience here. Because most of the audience we have today are also people who are into career transitions. They are probably doing something else, looking to transition into data analytics and these kind of technologies. So your story is going to be inspiring for all of us. Please go ahead.
Yeah, that's quite a good background, I think, you have given. And first of all, very thankful and good evening to everyone on the call. My name is Sharath, and I work as a principal data scientist in Microsoft Security Research. So prior to Microsoft, I worked in different aerospace and industrial related engineering organizations, which are mostly MNCs. So my profile is explained before. So I graduated as a mechanical and aerospace kind of engineering, and like every typical engineer, right from the college, you think through about, hey, how we're going to apply your science as an application. And traditionally, those days were more like, how you work in a big, mechanical or probably the digital side of it. Uh, but my passion, towards what drives these robots, or what drives these machines. In the last 10 years, if you see, it's all about data revolution. And it moved from a machine which you can tangibly feel to a machine which understands what you talk, what kind of data it receives, and it can also think today. It can give you an insight which a human being does. So that really is something which we thought through a decade before, and the passion which drives around to understand new things across the globe. That's pretty much what brings me, in front of all you people. So uh, yeah, that's pretty much on my side. So I mean, impacting everyone's lives across the world. That's the basic objective, right? Which we feel very happy for each and everyone. I think that should be the motto, which I worked on, and pretty happy with the people who choose such a kind of motto. So with that, my introduction, I would like to introduce also some very interesting trends which are going across the globe, specific to AI, and also the new trends in the AI. Right, people might have seen a lot of these news which are coming, right, and the open AI and how the big industry, I mean, especially from our company, I mean, our chairman has pivoted the entire deal, and you can see how that shifting gears around. So yeah, the big stakes are pretty big, and it is pretty important in industry, right? So everything, bottom line, the answer is AI. Earlier, if we look back a decade, the answer is about learning skills. Hey, what kind of software you work on, what kind of industry you are trending into. But I think people have moved on from industry to what kind of application you're doing. Is it AI? Which part of the AI you are into? So that game changing has happened in recent times, and it is because of the AI. I think the lives of many people, or even I would say the economies, have shifted from regular day-to-day kind of work to thinkable machines, artificial robots, which drive their product development, right? So I think we need to understand also certain principles. I would also introduce you a video kind of thing, where it's not just development, but it's also about what sort of rules we make for ourselves. So think like as a human being, we live by the rules, right? Similarly, AI is also something which has to live by the rules. That's called as ethics.
And
And
that's where responsible AI and these kind of discussions come into the picture, right?
yes, so some people say ethical AI, we call it as responsible AI. The legal and the judiciary call it as the legal AI in their terms. Name changes, but I think substantially the concept which is built around the block is same. So it can damage, it can improvise your life. Both sides are there. We need to channel, we need to tune it so that it caters our needs at the end of the day, and it doesn't do harm also. I think people will love to be in the direction as long as it is that way.
So, Sharath, before we get into the in-depth applications and all of that, to start with, because many of the audience here is also very new to these technologies, could you, in very simple terms, help us understand what is generative AI? First thing. Second
All
thing
right.
is how different are these things from large language models or natural language processing. So these are the kind of terms we've been listening, but for somebody who doesn't come from that space, they kind of, we either use it interchangeably or we don't actually understand the difference. So if you could bring some clarity there, and then we will talk about the applications.
Yeah, I think large language model essentially is part of my the deck which I want to touch upon today. But in a brief, I mean, it's a kind of AI algorithm, I would say, where if we look back 1990s is where people, if say that you have a document full of content over there, at that time the mathematics was mostly around you break those documents into tokens, and tokens is not something machine can understand. It understands only numbers, by the way. So we put that in the form of numbers, and those numbers, the the words to the numbers conversion was something which we used to do it in 0 1 kind of fashion, the bag of words kind of approach, and then again moved on to the embeddings, which were like a huge dimension vectors. So the drift in the game started when we started making these embeddings. It's not just about, a cat is not just a cat. A cat also belongs to a cat family. A cat also is something which is a carnivorous. Now, how many are linked to the cat family? So it's not just we; it's an ecosystem we are surrounded with. The understanding of a word has changed ever since then, and models evolved. The way a simple machine learning model earlier decade back, which was more like, hey, we try to develop a model, we try to understand by reducing the error, how well it can understand on what you have trained versus what you're going to see at the end of the day, to how well I can predict based on what I have known by far. So generative AI in one shot is all about knowing everything. It's like a four-headed god, in Hindu terminology. It's like a Brahma sitting in front of you, and you keep asking him anything, he will tell you the answer. It's as good as a guard sitting in front of you, in my opinion. So, to train such a huge, you need such a huge data as well, and it's as good as a crawler. It crawled the whole entire web source of documents, and it understood what it has to understand, and at the crunch they have developed a single model which is sitting there's like a black box. Think like a black box, it knows everything. Just throw it back what you want to ask, it gives you the response kind of thing.
In fact,
But
sometimes it is what surprises me. It is also able to understand the emotional aspect. If you say it in a polite tone, it gives a text which is polite. If you
yes,
say, you say you want to be stern, then it gives you a text which is stern. So
true,
it is not just understanding the words and the meanings of it, but also the kind of emotion behind it. I think that's
absolutely.
technology.
Absolutely, I echo with that. you can in fact control its emotions. It's not just uh, we ask how it responds back, but also you may have put a sentence which is having a different emotion, probably your own thought, but you may ask it to respond in a nice way. So that is something which is wow factor for me. We keep playing around day to day, but again, we also try to tune why it responds this way. Again, you keep changing parameters, and again, you feel like, oh, this can be made like this. Sometimes we get surprised by the way we try to play around with those parameters and all. Yeah.
Right. So essentially, generative AI is a technology that can generate content when asked.
Oh yes,
That
yes.
is the basic definition.
That's a basic thing which you can. Earlier you want to predict. It's not no longer you need to ask something to get the data. Now you ask, what do you want to know about? It generates for you. Because like I said, it's like a brain which has got trained on everything. All you need to know is just keep asking, like old days students, people they don't know. So kids, when they're in the kindergarten schools, they keep asking the teacher every small thing, right? Why is like that, what is like that? So this is as good as, like, I would say, so keep asking, it gives you.
I think the skill is in asking the right questions.
Yes, that's the trend which people are moving right now. How well you ask, how right you ask, and how precise you ask, so that it can give you a right answer. Yeah.
And it never gets tired.
Yeah, it's not exciting. It's a good
that
point.
that is on a lighter note. But Sharath would love to know the applications of this technology now that we understand how it works. What are
Yeah.
the different applications? Please take us through it.
So, oh, should I move on to the slides, or shall we just
Yes,
give?
please, you can do that.
Uh, can you see my screen?
Yes, yeah.
All right. So, yeah, precisely the right question. What kind of applications? So, tons of applications. I would say, let me take a sample kind of things. If we are in a um, aerospace industry, or probably even, I'll take a much simpler example, like, say that somebody is a lawyer, right? And his day-to-day activities is all about filing a petition, right? And probably moving that petition, searching that relevant documents from the list of contents, and finally identifying those most similar thing, and also from the judgment perspective, how close we are to the earlier judgments, like its prediction, right? It may or may not, the person may or may not take it, but how well the machine is bringing us the context around it, right? So everything, right from asking question till we make a judgment call over there, generative AI does everything for you. All you need to ask is, hey, you need to just ask the right question related to which particular topic, related to which particular document, what kind of persons are involved. So you can customize it. So if we take an year back, or 6 months, 8 months back, uh, this is scrawled on the internet, right? Right now, the we came to such a situation where you can customize to the databases which organizations are catered to. So that means you can tune your own data, and you can definitely allow the large language models to understand your data and ask the questions on your data. So that works more fantastic for the enterprises, right? So with that, I would just start the agenda, what we have today. Ethical AI is something which I would just touch upon as a brief with a small video. Why it is important, why it is very, very cornerstone for every AI application which we develop, and then what's the evolution of these large language models, where they're coming from, kind of thing, and precisely what is a large language model, what do they do, right? And how you use your LLMs in your organization. Like I said, prompt engineering, right? And how does it shape up like, and finally a very simple use case kind of thing. Just let me know if you can hear the video which I'm playing. Can you hear the audio?
Yes, Sharath, we can. Go
All
ahead.
right. Yeah. Thank you.
We know that when you create technologies that have the potential to change the world, you also have a responsibility to ensure that those technologies are used for good. And that requires thoughtful and deliberate work. AI systems are becoming more and more a part of our lives, but our laws are lagging behind. They have not yet caught up with the unique risks of AI systems and society's needs. So in the absence of clear policies and regulations, companies must chart their own course to define the steps needed to develop and deploy AI systems responsibly. And that's exactly what the Microsoft Responsible AI Standard does. It guides how we design, build, and test AI systems so that they can uphold our principles and earn people's trust. We introduced our first Responsible AI Standard in 2019. It was grounded in our 6 core principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. When we published the first version, we knew that we were right at the very beginning of our journey of moving from principles to practices.
We heard from our product teams that principles were great, but not enough. The guidance wasn't easily actionable. As an engineer, I understood the very real challenges of those being tasked with building innovative AI solutions for a wide range of customers.
There are so many thorny challenges when it comes to developing and deploying AI systems responsibly. For example, AI has the potential to exacerbate existing societal inequities and even to create new ones. Researchers are at the forefront of uncovering and understanding these challenges, so incorporating their perspectives into the standard was essential. We deployed our hub-and-spoke governance model to move the process forward. This model brings together policy leads, product teams, and researchers, so the core people needed to create and carry out actionable guidance.
Early in the process, we were stuck. We had started out trying to identify all of the possible paths we wanted to avoid. Then we had an aha moment. Instead of focusing only on the harms we were trying to avoid, what if we also shone a light on the societal goals we were trying to achieve?
Once we settled on this goal-oriented approach to updating the standard, we divided into smaller groups, 1 per principle, to develop actionable guidance. This involved identifying the requirements necessary to meeting our goals, as well as the tools and resources that could be used to meet those requirements. This was challenging work, and we had a lot of factors to weigh. We needed to strike the right balance of providing clear guardrails while allowing for new types of AI systems. We also needed our guidance to reflect state-of-the-art research on responsible AI, while making sure our product teams weren't left struggling.
What we started to find was repeatable, predictable patterns. We used these patterns to guide the requirements in the standard and to help us identify tools and resources that would be usable by the people tasked with building AI systems. We also recognized that there were particularly sensitive uses of AI that would always require expert guidance. One example is custom neural voice. AI has made great leaps when it comes to replicating someone's voice, but it's easy to see how this technology could be misused.
Our playbook needs to work across a large range of AI systems, and we want it to be durable as the practice of responsible AI matures. Around the world, we are also seeing more and more policy proposals to better govern AI. While we're proud of how far we've come at Microsoft, our updated Responsible AI Standard is just one step on our journey. AI will continue to evolve, and as it's put to novel uses, we'll need to be able to adapt quickly, be open to constant feedback, and have the humility to admit when we fall short of our goals.
We look forward to learning alongside our partners and customers as we strive to build a world where AI-powered innovations help everyone on the planet to achieve more.
Our goal is to build AI systems that can benefit everyone and earn their trust. The Responsible AI Standard gets us closer to achieving that goal.
Thank you. I hope this video might have given some insight, right, on what is about AI and how are we trying to envision about AI. So I'll give a crisp shot about what is about AI, right? When as a ethical AI, it's a kind of a term that refers to the development and use of the artificial intelligence systems, right? And that follow certain values, that follow certain principles, and that follow certain standards to ensure that there is a responsible and a fair, transparent, accountable, safe, secure, um, and a respectable, of human rights and the environment. Right, so it's an important term where it can have a significant impact on the individuals and the society as well, because such as influence those decisions and those behaviors, opportunities and outcomes as well, right? So why these are important precisely is because AI systems can also pose risks, think like a bias kind of thing, and some discrimination, probably some sort of privacy breaches, right? Which happens in something like a Twitter or some Facebook kind of thing. Somebody hacks some other account, it's a privacy breach, right? And it's a manipulation or probably a harm or some misuse. So in order to ensure that AI systems are designed and are used in such a ways where it aligns with the moral values of the human beings which we set ourselves, and also the interests of the humans and the common good. So in short, it's an evolving field. I would still say it's rather than saying, hey, I've laid down the rules and probably excuse me, so I laid down the rules and probably we're just going to follow that. I would say it's rather more dynamic and it's still evolving field, because the dialogue which essentially involves during the conversation, right, and also the reflection and the collaboration between various stakeholders, because ethical AI is all about we need a commitment from AI developers, the users, the regulators, the policymakers, the researchers, and the civil society, right? So it's an interdisciplinary one and a cross-cultural thing. So that's the essence of about thinking, ethical AI. And every AI developer, a research scientist, should have his thought process. One end of his thought should be always aligned with ethical AI. With that, I would just introduce you to this, the evolution of the generative AI, which is the topic of today, and what essentially where it is coming from. So if you look at this artificial intelligence, AI in short, and the machine learning, then the deep learning and the generative AI, where they're coming from, and what is essentially, their importance in day-to-day life. So it's around almost like 75 to 80 years back. There's something artificial intelligence is more termed as a computer science branch, where you have some sort of an algorithm or probably an intelligent machine. A robot in those days is more like an intelligent machine where it can map with the human intelligence, right? And uh, during another 40 years, I think if you look at the history of the computers and the evolution of software, The 1950s till 1990s is all about the evolution of three things. One is the machines. Originally, computers used to be huge transistors, right? And then it came down in 90s to a size of a small CPU kind of box, right? And then there are chips which are came from a very huge boxes to a small chip which is a size of the palm kind of thing, and the computation power essentially. There's a bottleneck until 90s where the computation power is a huge challenge because the amount of data one can process through a small chip, and with the kind of memory it can hold up is not so developed during those early 80s or 90s, I would say. But much things have changed in the 97s, 90s, and 97 is something where people would term that, hey, ML came into existence because we started looking around Intel processors getting more and more powerful. And the branch of AI, which we were thinking through a couple of decades back, like, can we process a huge amount of data? And can we make some decisions? Can we make some predictions kind of thing, which pretty much viable in 90s. And as we moved along from there, architectures and the models started maturing enough, right? From a simple machine learning model to something which is more complex machine learning models like the SVMs and the boosted trees or kind of things. And slowly, things started moving around. How can we really understand an image or probably a speech signal or even some sort of a text data, right? Then what we saw in the early 20th century, we can say like around 2010s around, deep learning is something which came very as a solution, as a go-to answer to solve a lot of these unstructured data kind of problems. Neural networks, which were more, I would say, which were more mathematical and hand calculated, now became much more possible to program and get it computed as well. Today, if we see, we have TPUs. Google shares the tensor processors in their Pixel phones, right? And similarly, the NVIDIA, the kind of CUDA processors which they produce, they allow us to do gigabytes and petabytes of computing. So the art of deep learning has evolved in last 10 years, and where we are today, the generative AI, which we are talking, it does the computation in the cloud, which consumes the data which we can't even imagine. It's an unimaginable size of data crunch which happened, and the kind of curation it does, and finally to reach about a certain level of understanding. um, it's a massive, unimaginable kind of computations. It has been done on top of that, and that's the reason why we see today a buzzword, something like large language models, right? And there's a generative AI, which on top of that, it's a coding, which allows you to, write anything, whatever you think around it. Just ask the system, it throws back with a very nice response, right? Be it a text script, probably an image kind of thing, which is like a DALL-E. DALL-E is an OpenAI model, right? It's a very popular model which generates as image. When you write something like, I want to know about a deer in the forest, so it generates that image, right? And similarly, a kind of speech where an assistant kind of system. So the fulcrum has moved from rather than developing complex models to writing an prompt, where if somebody can teach themselves how to learn the art of prompting, how to ask the right question. It's as good as in your school, somebody would ask, how well you know that you understood well. Is she asking the right question, right? That is the essence around the prompt engineering. So if we move on to the topic which we really want to focus upon today, the large language model, right? Um, It's a type of AI, I would say, which can process and produce natural language text. So in short, it's a think like it's a kind of a black box kind of thing where it has been trained on the entire massive amount of text which is available over the internet, over the web. So it crawled the whole the tons of data which is there, and it understood different kinds of things which were lying around in those texts. And people might have thought about how does it store and how does it understand all these things. And when we ask a question, how it is giving us the right answer, right? And essentially, it creates some sort of a graph, or probably it discovered some sort of a pattern depending on the query you ask. So there is a search engine which lies behind it, and there is also some sort of a rule-based system depending on the kind of question you ask in which particular language, right? So because of that power, it can do various tasks like questioning, answering certain questions, simple to complex, give a give certain text and ask it to summarize it. It very well does that. Or you may also want to ask to write some poems kind of thing, which is more creative in nature, right? So a lot of artists, I think, in Hollywood and elsewhere, they're using this, script writers. I mean, they're using to generate the stories depending on their thinking process. And also, you may also want to understand the historical things, a very, very large amount of incidents which might have happened in the past. Instead of reading a huge book, people are trying to understand in a brief, right? So all these things which elsewhere we thought a decade back may not be possible, how it might happen, it's possible today by asking the right question. So the center is how well you want to ask, or how precisely one asks in the least amount of words or tokens the system can take. The large language model will try to process that question and tries to understand what is the context of the user or what he's trying to ask, how relevant I can find that particular content in the system. And it generates um, uh, such a answer from it. It might be abstract, it might be creative, or it might be informative, or very deterministic, which might be there in the information, but it brings you in the best possible manner. So in brief, I would say that it's a language calculator. Why I'm saying this? I mean, um, a large language model, if we look from 60,000 feet kind of elevation, it appears like, hey, I see some sort of a very powerhouse over there which has a full understanding about all the kinds of data which it can encapsulate. But another way of looking at is, if we used to do mathematics using calculator, right? We just if we want to do the multiplication around 5 digits cross 5 digits, calculator can do that in a brisk of time, right? That pace at which it does over the numbers, can we do that with the processing power of a human brain from a machine? It's a language calculator, right? You ask a question, it brings it back an answer, right? Everything is in natural language. What you ask is a natural language in English. What it brings back is also a natural language in English. So that's the reason we sometimes, we can brand it as a language calculator, the way we can see that. But like a calculator has a ceiling limit and how much it can throw it back, systems also have a limitation. Like people might expect to answer it another 30,000, 40,000 kind of tokens in an answer. Maybe it may not be a possibility for the system, but it gives you everything in a defined fashion or in a limited scope, the best it can answer. And a large language model does that today. So let's double click this language calculator, right? And if we see through, by taking a simple example, yes, I'm sorry, somebody has raised a hand.
I guess we'll take questions in the end, Sharath. You can go ahead.
Okay, yeah, thank you. So I would take a very simple example here, something like, say that somebody is traveling for a trip to a Patagonia. Patagonia is a place where it is more like chilled in the winters over there. And think like there's already winter for us in India, right? If somebody wants to go to Kashmir, uh, whatever the sleeping bag which you are trying to carry it forward, will it make sense? So probably you might sleeping bag, you don't know what's the dimension which you want to carry forward, right? So it's just a very vague input what you're giving out there. But what's the interesting part here is if you don't know precisely what you want to ask, you can mix up with the kind of prompt engineering in the second bit, what we see here, like, hey, I know about, I need to carry a sleeping bag for my trip, right, to a Kashmir kind of thing. But you can add something like the historical weather, a month around, what's the kind of temperature Kashmir has, or probably it might be a chilly winter. Will one sleeping bag is good enough to work my trip well, or probably how thick my blanket should be, right? It's a kind of question which you would expect a human being to answer, or somebody might have traveled to Kashmir or probably some chilly places where they have experienced it well enough, right? So the context is pretty important, and there is a very very personalized question, because you care for what you want to get the answer over there, and also you expect that there is some sort of a recommendation which a system might give in this particular case, right? So there are different dimensions which are considered in this particular scenario by a system like large language model, which takes a regular user input. It weighs upon different parameters based on which his particular context is weighing around, and then it tries to map different relationships between each of these things, and it ranks them or prioritizes them based on the best possible answers it will bring in this particular scenario. And finally, the answer we see at the right end is something like, hey, your light eco sleeping bag is rated around 21.6 Fahrenheit, which is way below the average low temperature in Patagonia in September. Now, it really brings us a wow factor to understand how it is deciding this is not suitable or this is suitable, this is above or below kind of thing, which involves a lot of analysis like a human being. So the kind of like I mentioned before, the kind of training it went through a particular AI model, that is a background based on which it understood that if you're mentioning a place like Patagonia, if you're mentioning a place like Kashmir, so the immediately it understands the various relationships around that particular token over there. And you're asking next month, so it should know which month you're lying around, right? So there is an intelligence which allows the system to think that this place with this time context, if somebody wants to travel around, what kind of things he should pack for and what sort of precautions he has to take. It develops the entire network over there, and that's how it arrives at this conclusion. But still, I would say this is still a vague question. If we go a little deeper, we may also want to know about how the output is calculated, right? So in the earlier example, if we see, it talked about, hey, the blanket or the kind of sleeping bag which you carried, whether it is work or not. But you may ask a question, the sky is what? So imagine if you ask this question to somebody like a kid, right? The sky is what? The kid will say it's blue or very hue in color or dark in color or probably very bright in color. So the kind of training a kid went through by looking every day in, day out, the kind of training the model has done is pretty similar because of the understanding which it has got uh, over the kind of data, a massive amount of data it went through, it can fill the blank over there. So you can see that it weighed upon different possible options here. A blue has got some sort of a score. A sky can be clear as well. So usually is something, it's because every time there is sky, there is a possibility that usually the kind of words which come along with that, associated along with that, right? So it's a kind of a way we use the English language. So it ranked them in a sorted manner, and then it decided that, hey, blue makes more sense for me from the systematic point of view. And I would say throwback that the sky is blue. So imagine if the clear has got much higher score, then if the sky is clear, blue might come later on, right? So it's a thought process. Eventually, in this case, the answer may or may not satisfy the individual, but it has got an thinking which has some power to ensure that why I am giving this answer. Now, people can tune this based upon how relevant you ask the question, right? You may would like to ask, is the sky clear? Is the sky clear, or the sky is blue, but is that clear? So probably it might weigh in terms of the the prompt which you're asking, and precisely it would mention clear as a context over there. So when we talk about the large language models, traditionally the steps which are involved in also matches with any ML model. So the hierarchy of a language model and the way we train day in, day out is pretty much the same. You bring the training data, you train the model, test it, and then you productionize it. So similarly, the language model is more like, it's since it's already trained, all you need to bring is either you ask something on which it has been trained, or probably you bring your data. That means you add your data, right? That's the fundamental base of this inverted triangle here. And what you do immediately is ask the question, right? That is called as prompt engineering. So prompt engineer is all about asking the right questions, in short. Now, 90% of the time, people would always focus on this as the biggest, achievement in terms of utilizing the LLMs. But one never know that whether it answered the right question, like we saw in the last example, the sky is blue or sky is clear, what sort of expectation we have, right? So that is the margin of 25%, which we say we have to fine tune. And how we're going to fine tune is you provide the example, right? When you provide the example based on what you're thinking, the AI tries to understand your context, and it tries to tune according to your thinking and aligns with your question. And that we call it as a fine-tuned language model. And then it gets retrained, and that's how it starts generating the answers aligned with your thought process. But keep in mind the left-hand side, while doing all this procedure, when it's bringing answer based on the question you ask, responsible AI is a fundamental block. Is in short, it's an ethical AI, which is the background based on which it's throwing an answer back to you, which is not violating the language which we want to know about, right? Now, you once we know the LLMs, right? We usually we try to play around with different sorts of questions, right? And obviously, one would love to try and experiment. Hey, how can I generate an application based on LLM, right? It's as good as build your house with bricks and mortar kind of thing, right? So you know your LLM, and now you want to ready-made an application which is based on the LLM's power, right? It's as good as you add your data and then you tweak around the data, and then you get a new model, which is a fine-tuned version of the LLM. Think like it's a kind of a specific organization, specific data, or probably something related to maybe a legal kind of data, or probably a medical data in specific, right? So when you tune it with respect to medical terminology, or probably some sort of ailment or a disease, it understood that you want to tune according to the medical translated knowledge, and then what you build an application after they're tuned is very specific to the medical related terminology. Is as good as building your house depending on the shape you want, right? So the way I try to explain everyone here is how well you build your house, right? From the different perspectives. LLMs are also designed in a similar perspective. You have three kinds of things, right? Where it's ready-made, or you want to renovate the old house, or you want to customize your old house, right? What's the kind of time frame it takes? What's the kind of time frame it takes? You need to get permissions, right? You want to get the utilities out there. You need to have a foundation set up, then the exterior portion of it, and the interior, and everything is done. You put the furniture out there, and how much time it takes for each of these things, and finally the cost, right? If somebody wants to do from the scratch, it takes a lot of time, and also the cost, right? An amount of money and the time and the resources one needs to involving is so huge. So similarly, if we try to understand the LLMs, any organization, if they want to build a model from scratch, it would take a lot of cost. It would take a lot of time for the systems to understand, to tune it, to process it, right? And also it would also weigh upon a lot of resources as well, right? And there could be the need. Every model is pretty customized to your needs. So that means every time you have a new ask, you need to develop a new model altogether. So think like it's more repeatable kind of thing, model development you do at the end of the day. On the contrary side, if you consider LLMs as a replacement, it's a kind of abstract thing which you can customize according to your needs. So the amount of effort or the resources one might put here is way less than when compared to traditional model development, because the model is already trained on tons of data around the web. So all you need to do is make it understand according to your data. So customize it as per your will and just fine tune it so that it got trained on your new data and it understands what exactly you want to ask around it. And look at the cost it incurs here. It drops from 100x to 1x. And that's exactly the enterprises or the large corporations or the companies might be interested in, right? Every time building a new model, when it is taking a lot of time, and the kind of cycle which they have to develop their products, if it is too short, then the insights or the analysis also will take a lot of time. And so LLM is the right answer in this case, where it can get you things done in a much lesser time. So the very first step, where the hierarchy, we're starting with adding your data, that's the most important thing in fine tuning your entire large language model, customize or cater to your needs. It's like bringing your vegetables. You can make any kind of dish. All you need to know is what exactly you want from it, right? So bringing your data into the vicinity of it, it's a most important preliminary step. Now, if we go a little deeper in the large language models, and especially when we are saying that, hey, ask the right questions, right? What we are talking here is an augmented generation kind of thing. So what it means exactly is user asking a question. What it does backend is it just queries your data a query is as good as you have a database, and you imagine in a bank, if an employee types a particular query that, hey, I want a record of Mr. X. So at the back end, it goes to a database and it searches the index, gets back the result, right? It's exactly in a similar fashion. The retrieval of this particular augmented data on top of the LLM, it allows the system, the LLM, to think through about what you have asked versus what is the index or the indices against which it has stored in. And the results are queried back to the large language model as an input. And finally, what you also get in return is a simple natural language. So the way you ask is the way you get. They're exactly matching with each other in this case. But what runs behind is a kind of search query, a similarity kind of pattern, which is run by the large language model, which is all about the relevance game, the question and answer. Now, let me take a simple example here to just understand this bit by bit. So a prompt says you're an intelligent assistant helping ABC Incorporation employees with their healthcare plan questions and employee handbook questions. Now, answer the following question using the data provided in the source below. So this is a kind of text input that provides some framing as how the LLM should behave here, right? So we are trying to tell the LLM that I am asking you to behave as an assistant, to these ABC Incorporation employees, so that you can answer the healthcare related plan questions to them based on the understanding it has got. Now, user has asked a question: does my health plan cover an annual eye kind of exams here? That's a question user has asked about the eye related checkup kind of thing. So it went through, search the index, and it just broken down. The LLM has tried to understand what you're asking is related to health plan, and in specific, you're asking about eye related concern here, right? So like we have seen in this particular case, it queried the data, went into the index and added the results which are related to all the healthcare plans, and then it narrowed down to another token which is eye specific, and then it threw it back to the large language model, and then it started to write in a language which is allowing you to understand from the response, right? So if you see this based on the provided information, it is trying to cater all the health plans over there. So the Northwind Health Plus offers coverage for vision and glasses, lenses, and so and so. And then it is saying like, there is a coverage for this service, even for vision and for dental. So I think it's trying to help you out the way you're expecting, right? So the power of LLM is all about making sure that how well you want the search engine or the GPT kind of the large language model engine which behaves behind the scene. So with that, I would just touch upon a very simple and very popular use case. Think like a call center. And let's spend some time in understanding this. There is a contact center analytics where day in day out they receives a call for a particular product. It's more like a person to person kind of conversation, right? They may put a complaint, they may ask certain question, or they may even tell the feedback kind of thing, right? Everything goes via a telephonic server, and every organization, think like an Airtel, right, or probably a BSNL kind of thing. When the exchange happens through a medium, they would store every possible information into a particular database. It definitely, the size of which gets stored is very mammoth, right? There's billions and trillions of calls, and when we want to store such a huge humongous data over there, either Azure or AWS kind of thing, where we store each and every audio file, and somebody wants to understand at the a call center level that, hey, what all did we chat? We would just like to see the summarization of it. Maybe probably like a call center head who wants to understand the context behind how many calls went through, and what are all the kind of questions which have been asked, and what is the kind of response we have given, and how a typical conversation went through, right? And if we take this particular scenario, the intelligence portion of it lies in the center box over here, As you can see, the audio files are processed inside the system. The intelligence portion of it, it translates the speech into the text, and this text is processed inside a large language model. And it all tries to understand what the conversation between the two people and what is the context around which they're talking to each other, who are the stakeholders behind it, and are there any specific information which a user is interested in. Now it digresses everything into different bins and stores it. And once it gains an understanding about different aspects of the conversation, then it tries to segregate that into different bins over there. So the exploration part, it's about questions which user has asked, right? It's a chatbot kind of thing based on the conversation. User would like to ask who are all involved during the discussion, or probably what did user asked to the call center person, questions like that. Or probably if there is some business related information which has been shared upon, what kind of insights which we derive around in during the real time. Or probably even the customer satisfaction related, the typical CRM related, how well the customer is satisfied at the end of the day, right? So if we look at the whole architecture here, this is pretty much how an LLM can really solve the problem right from a typical audio file, or the size at which a carrier operates in a day, billions of audio files, and get the understanding about what somebody is trying to talk through during this particular frame of time, and what are the most trending topics out there, what are the most important topics. Imagine if there is no LLM, somebody has to really process this and do all the statistics behind it to understand the most important things, which are probably the top 10 things which are discussed during that particular period, right? It involves a huge model development. But the LLM has got the power, which is already, it has got all the necessary understanding given the text. So all you need to ask the right question, and which gets tuned to the LLM. Now, if we look at an actual scenario, the example perspective, the same contact center summarization, user would maybe interested to ask the manager of the contact center would love to ask, summarize this for a call center agent, ABC kind of person. Now, immediately it brings you all the discussion which went between A to B, and with this agent customer conversation happened, the completion gives us the response, what they have discussed, the entire summary. The agent is speaking to a customer named Peter Smith. Peter is asking for tips for manual payroll processing, and the agent also, informs Peter. So this is a kind of summarization which it does. And finally, the job becomes much more simpler for somebody who wants to understand about how well he can solve the problem, or how well he wants to understand the reasoning behind, day-to-day activities. With that, I would take a pause, and I would love to answer the questions if somebody has. Thank you.
Thanks, Sharath. That was, a very simple use case. I think something that we all experience and encounter at some point of time. But probably for us, it never struck that LLMs can also be used for these kind of purposes. I think going by that way, the applications are like unlimited. Almost every industry, every domain, you can find applications of these kind of technologies.
Yes, like you said, applications are countless. I mean, be it a simple banking organization, financial, uh, think like a stock trade kind of thing. You have the whole list of last 10 years of stock trade incidents which happened. People, if they want to really understand, how many of them are and manipulations happen based on what reasons, right? If somebody wants to do that manual kind of analysis, even by generating a model, it would consume a lot of time, because you have to tune on an entire data set over there, right? The LLM, on the contrary, since it has the knowledge, and all you need to do is think like a brain, and you just feed some input to it. It does the magic for you, and what you get there is the analysis which human does at the end of the day. And the kind of factor it brings you at the last minute, like, hey, respond to me in a nice language, probably you put me in a very deterministic manner, 1 2 3 kind of thing, it does that. So quite a system which it works in a fashion we want.
Right. So there's some basic questions. Probably we have time for 2 to 3 questions. So
Yeah.
one of it is for somebody who is very new to this field, if they have to develop these kind of models or even get an understanding of them, what are the languages or what are the technologies that they need to learn um, to build these kind of things?
Yeah, a very relevant question. I think uh, I would give a very basic level. Think that if you don't have a good understanding about programming, I would say number one is programming. At any point of a day, one needs to have a hands-on about, if you want to develop a large language model, you need to be very thorough on the mathematics behind it, the Pythonic kind of language. Language is something which one can adjust. I mean, if you're comfortable in C, C++, or Python, it all depends on the individual. But I would say programming plus mathematics is all makes the wonders. But think like you want to use it from the application point of view. If you want to just use it for your business perspective, all you need to know is how you can shape this with the relevant prompts. So the importance lies there is prompt engineering. It's not about you learn the language, the programming language, or the elsewhile. Most of the machine learning engineers or data scientists in the last 1 decade, people have spent most of their calories on, right? That's not the thing. If you want to aim for a prompt engineer, if you want to develop a large language model, mathematics and the data programming kind of thing, which one should be acquainted for.
Specifically in mathematics, any certain areas that need to be focused? I can see a lot of mathematics behind you, actually.
Yes, precisely. Yeah, I mean, a lot of these vector algebra is a fundamental part of this, the differential calculus, because the more you try to do the similarity search, because it's all NLP at the end of the day, natural language processing, right? And the way we transfer the amount of data is in the form of mathematics, is numbers, be it a decimal form or an integer form. So you need a matrix, vector algebra kind of thorough understanding about this, how you can apply the differential and the integral part, because that's where the smoothing of the error comes into picture, the transformational mathematics over there, the calculus I'm referring to. So apart from that, the set theories, which are also very vital, a simple Jacquard similarity would tell us like what's the commonality between the two sets. But as we keep moving on from different sets, it's not just two sets, it's multiple sets. And the way we try to dissect the problem there with the weighted correlations will change the game. So every portion of vector algebra and the set theory makes a lot of sense for this.
Right. Is it important for the beginners to have some understanding about cloud technology and all these kind of things also?
Yeah, it allows them. Cloud is where all the data, how well you talk to the data. So if we look at any enterprise, uh, the popular clouds are Azure, Amazon, AWS, the Snowflakes, GCPs, which is Google's, right? So tons of these data which get stored, over there. The model. Uh, so we have to take a step back and see what sort of models are we developing. Is it static data, which is accessing the data on your system, or it is accessing on the cloud, right? So from an enterprise perspective, people would always value the skills where you also know about how you interact with the cloud and its peripheries over there, because static data allows you to do the statistics given the data on your system, right? But cloud is something where you do real time. Think like a Twitter. The tweet which gets highlighted every day, or probably the Facebook post which gets more number of likes or dislikes, it changes the game in the next 1 hour. So interacting with the cloud is quite crucial in the modern day. I mean, it also allows you to understand how you can scale an AI application at a large level. Apps, all the mobile apps is all about interacting with the cloud. They launch it on the Google server, right? So it's a must-have skill in my opinion. Yeah.
Great. So one last question: how to become prompt engineer?
Oh, that's a fantastic question. So prompt engineer, I would say two important things. One is understand. First, you need to have a thorough understanding on the domain, because not everybody can ask question, but everyone cannot ask the right question. A right question can be asked only by the person only when he knows about what he wants from that system, right? Whether he meets his needs, or whether it answers his thought processes. So number one is have a thorough understanding of the domain. And number two is, for every prompt to make it work, prompt engineering should also be made through making the system understand to your needs. One, you know about the field in which you're working. Number two is making sure that system also is aligned with you. So bring certain examples where you feed the system to make it understand that this is what I am trying to ask questions which is similar to this sort of example. Now, when you make the system understand, giving the right kind of examples, which we call it as one shot or multi-shot kind of thing. So a zero shot is where you don't provide any example. So all you believe is system got trained and you just keep asking. One shot is where you provide one example, and it allows the system to think that most of the questions are based on this sort of example. Multi-shot is where you have different sort of examples, a variety of examples, right? And then it tries to understand the variety and the kind of inputs you're providing. And it makes the system to think in a very, very diverse manner. So two pretty important things in short. One is, understanding what exactly the domain in which you're working on, because you have the knowledge. Number two is giving the right examples so that system also can understand based on what you ask.
Right. Thank you, Sharath. Thank you very much. We have overshot by 8 minutes, but I think it was a good 8 minutes of interactions and some common questions that it's really worth answering, these questions. But great having you. Thank you so much for that talk. We'll keep coming back to you for more, probably, later on different topics, but it's really nice interacting with you. Any last words of advice for our learners here, all aspiring to be in the field that you're already in?
I would give my best wishes to each and everyone. I think this is quite a time for people to learn about AI, and especially the era which we are in. It's quite inspiring era, right? And things are happening so fast, and everything, the day in day out, you see something happened yesterday, something happened today. There's no relevance in the kind of technology we are playing in. So have passion and keep learning every day.
Thank you. That was great. Thank you so much, Sharath.
Thank you.
Have a great evening. And thank you, all of you, for being a part of this. And we'll come back next Friday with another great talk. Sai Chandra, over to you, please.
Thank you, Sharath. That's a wonderful session. And thank you, Shruti.